Hey, what's going on, guys? It's Mr. Sanchez coming at you with another video for pre-calculus. We're doing section 4.1. It says part one, but really it's part two. We did part one in class, and we're going to be focusing on polynomial functions and models, mostly polynomial functions. Our learning target for today is to identify the real zeros of a polynomial function and their multiplicity. Now we're saying real zeros because there are such things as imaginary numbers and imaginary zeros. And we're going to go over those in about 2-3 weeks. All right. Definitions. All right. A real zero. What is that? It's probably a new phrase for you. So if f is a function and r is a real number for which f of r is equal to 0, right? So f is some function, r is a number. That means if you plug in r into f, you're going to get y is equal to 0. Then r is called the real zero f of f. In other ways, that x value, in other words, the x value that makes your function slash f of x, f of x or y equal to 0 is equal to 0. So basically it's your x-intercept. R is your x-intercept. So r is a real zero of a polynomial function. R is an x-intercept with a graph of f. X minus r is a factor of f. And r is a real solution to the equation f of x plus 0 is equal to 0. All right, that's what a zero is. That means it makes our y value 0. And then you see this nice little graph here. We have a couple of zeros. All of these would be right here would be real zeros of this function f, right? All right. So given some information, let's see. It says find the polynomial function from its zeros. All right, so it says find a polynomial of degree 3. So we went over degrees. That means our highest power of x is going to be 3, whose zeros are -3, 2, and 5. All right, so basically, you're going to do the opposite. So how would you find them? You're going to say that f of x is going to be equal to x minus this number, x minus -3 times x minus that 2 and x minus that 5. All right. So this ends up being x plus 3 times x minus 2 times x minus 5. All right, if you do everything correctly. Now we do want to find the whole thing. So you're going to do a little bit of multiplication, right? So x times 3 times x minus 2 is going to be x squared plus minus x plus 6 if you don't believe, and then you're going to keep x minus 5 here. If you don't believe me, you're going to have to follow that out yourself. So, you're going to do, and I'll show you right here. That's going to be x squared. Oh, this should be a plus. Minus 2x plus 3x minus 6. Right, so just a little mistake right here. It happens. So it's going to be x plus x. All right. And then if you don't know how to do that, we can always do the box method to find the last part. We're going to have x squared, x, and 6. We're going to have x minus 5. You're going to draw a box, and then we're going to add some stuff up. All right. So you should know this from algebra 2. X cubed negative 5x squared, x squared, negative 5x, 6x, and negative 30. So we're going to end up that our f of x is going to equal to x to the power of 3 minus 4x squared plus x minus 30. So that's going to be our polynomial whose degree is 3 and zeros are -3, 2, and 4, and 5. All right. All right. Identifying zeros and their multiplicities, all right? So we have another definition. And you're going to be doing this. Well, first of all, we're going to be doing a couple of these in class, so it shouldn't be too hard, okay? All right, next up, we have identifying zeros and their multiplicities. If x2 minus r to the m is a factor of a polynomial, so like right here, x minus r, right? That's a factor of the polynomial. And then, so right here, the power is 1. But let's say x minus r to the power of n plus 1. So it's not a factor. So that means, like, let's say you have x minus 2, but x minus 2 squared is not a factor. Then what we're going to say is r is called a zero of multiplicity of m. All right, so it's going to be very straightforward here. Okay, so let's look at our first factor here. Our first factor here, x minus 1/2 to the power of 4. So right here, to find out what the zero is, it's going to be the opposite here. So the zero here is 1/2. It has a multiplicity of 4. Okay. Right. We also get x equals to -2. That's the other zero. That comes from this part right here. And that one has a multiplicity of 1. So if you don't see a power, then, that's about it. All right. And then this last one is 0. All right. And so x equal to 0. That one has a multiplicity of 2 because the power is 2. All right. And you can see here that the degree of the function is the addition of all the multiplicities. So we have 4 plus 1 plus 2. The degree of this function, you can just add up the multiplicity. So 4 times plus 1 is 5, plus 2 is 7. All right. What does even and odd multiplicity mean? Even multiplicity. So if our multiplicity is even, that means that when we see one of our intercepts, our zeros, we're gonna touch the y-axis. We're not gonna actually the x-axis. We're not gonna cross through. If you have an odd power multiplicity, then that's when we're gonna cross through. Okay. All right, let's move on to the next part. Investigating the role of multiplicity. I just said this, right? So you're gonna write this down. If R is a zero of even multiplicity, the graph touches the x-axis at R. So it's gonna be a nice little curve on the line. All right, if R is a zero of odd multiplicity, then gonna cross the x-axis. All right. All right, now let's just go over some easy stuff that we've done before. And let's find out. All right, let's see. So let's go ahead. It says here, find the x and y intercepts for these. So for the x-intercepts, so that means we're gonna do x plus 1 squared times x minus 2 equal to 0. All right, you can split this up and you're gonna write x minus 2 equal to 0 and x plus 1 equal to 0. You don't need to include the square because 0 squared would still be 0. So we're just gonna make the inside of the parentheses 0. For this one, you're gonna do plus 2 plus 2. So we're gonna get that one of the x-intercepts is 2. So that's a 0. And then minus 1, you're gonna get x is equal to -1. So these are your x-intercepts. Right, so that hasn't changed. For our y-intercept, you're gonna let x equal 0, right? So instead of having x plus 1, you're gonna have 0 plus 1 squared times 0 minus 2. That's what f of 0 is gonna be. That's our y-intercept. So you're gonna get 1 squared times -2. 1 times -2 is -2. So that's our y-intercept. All right. Next up, it says for each intercept, determine whether it is odd or even multiplicity. So for x equals 1 or -1, that has a multiplicity of 2. And for x equals 2, that has a multiplicity of 1, right? Because there's an invisible one right here. And that's about it. Okay, guys. I don't believe we have anything else for this section. This is for section 4.1 part 1. And we'll do 4.1 part 2 the next day after today. All right, guys. Have a great day. And if you have any questions, feel free to ask me in class. We'll have a lot more examples in class. In my math lab too. Yay. Bye.